Win Chang here, inventor of the ShoulderSphere. I today have volunteered myself to have a needle EMGs performed on my rotator cuff in the shoulder. This is to evaluate the function of my rotator cuff during 3 different sets of conditions: shoulder at rest, shoulder during motion without resistance, and thirdly, under conditions of exercise that is specifically designed to strengthen the rotator cuff, with my ShoulderSphere versus the control group of the ThoroughBand, the standard rotator cuff strengthening ThoroughBand. I don't know what the results will be, but we will see. And I'm introducing Dr. Kishore Ranade. He's the clinical assistant professor of neurology at New York Medical College. He has over 25 years of clinical experience in performing electrodiagnostic studies. He also is board certified in multiple fields: neurology, clinical electrophysiology, electrodiagnostic studies, sleep medicine, and even medical acupuncture. So we're very fortunate to have Dr. Ranade to perform my needle EMG studies of my rotator cuff.
So what we are going to do today is insert a needle electrode, which is sort of an antenna, in a couple of muscles of Dr. Chang, and see how the muscles are working. We're going to look at the firing of the motor units, and a motor unit is essentially a collection of the nerve cells and the muscles that go with the nerve cells in that particular muscle in the rotator cuff that's going to get excited and start working. And we're going to have a screen display that'll show how the muscles fire, and we have an audio hooked up to it so we can actually even hear as the muscles get recruited as more and more force is exerted. So we're going to take this needle electrode. In technical terms, it's called a concentric electrode. And the reason it's concentric is inside the needle there's another wire that acts as a negative electrode, and the outer needle that you see is the positive electrode. So when you have a negative positive, it's like 2 pieces recording. And this will be inserted in the muscle, and this will detect as electric currents are being generated by the nerve in the muscle. The spine of the scapula, go right below it. It's a thick muscle. You have to go through the trapezius. He's got a thick, yeah, okay, here we go. Okay, now we're in the infraspinatus. And how do we know we are? Well, we check the activity. Okay, that should do it. Now, so you can see at rest, the screen is flat because there is no nerve sending any messages to the muscle fibers to make them move. So then now we recruit the muscle. So you can even abduct. There you go. And then you can see that it starts firing. Now, do it less, very little. Rest, 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 rest. Okay, that was
okay. I'd like to look at this screen.
Yeah. So now you
very interesting.
Yeah, you can actually get your good feedback this way. So actually, let's do external rotation. Might be easier.
Oh, look at that.
Just stop. No, you're still firing. Let go. Yeah, that's it. So you see, anytime you abduct, again, now push. There you go. Now let go. Now just elevate. Now just elevate your shoulder.
Oh.
It's less. You see there you're using the trapezius. This is to make sure we're not in the trapezius and we're in the infraspinatus, right?
Yeah.
So, okay. So we can just isolate it. Yeah, now pull out, push out. Yeah. Push, 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 push. Okay. So there you have it, right? So this is infraspinatus, normal muscle. And at rest, there is no firing. And usually what we do when we are actually studying doing EMGs on people, we like to get an audio because often, believe it or not, if there's any abnormal signals, they have such a characteristic audio signature, and the human brain is better at detecting noise changes than visual changes. So this is how a normal sound would be. Okay, rotate externally. Push. That's right. And if there's any dropout in motor neurons, so there's some nerve cells that are not working or some muscle fibers are damaged, you can actually hear the interruption in that sound. And after you've trained on this a while, you can actually close your eyes, put a needle in the muscle, and know exactly what the problem is. Because the audio recognition is so quicker. Okay,
Okay, this is a totally at rest, neutral position. And then I'm going to start to do the shoulder sphere.
So you can see there is a distinct pattern of firing. His muscle, you can say, is firing at a rate of about maybe 6 to 7 hertz. 6 to 7 times a second. And here, if you just turn around, wait, I want to show you something. Do it again. I'm going to check. So this is a time base of 100 milliseconds. So if you can fire so it stays right here,
right,
you're firing at 10 hertz. If you come here, you're going at 12 hertz. As it goes there, you're going maybe at 6 or 7 hertz.
Right.
Okay.
So I decrease the velocity of my RPM.
Right. And this is,
you can see this.
So these are the muscles firing, stopping, firing, stopping, firing, stopping, firing. So it's not a continuous thing.
Right.
But you get an interruption on, off, on, off,
right.
on, off,
So
on.
now I'm resting. So the muscles firing. So that demonstrates in position number 2, it also hits the infraspinatus. So in order to keep it spinning, all the energy is derived from the rotator cuff, because the function of the elbow only goes up and down. As you notice that the wrist is locked in position, so I cannot cheat by movement of the wrist. Alright, so now go to position number 3, that will be the forward plane.
So now this, of course, is going to be engaged at rest because it is working to keep, you know,
supported.
Supported. Even if you support it,
got them
though,
both?
you know. Okay, now go.
That also fires it. So position 3 also fires the infraspinatus. Here's position number 4. Also hits it.
Yeah.
What is the hertz?
This is we're doing less. We're moving to the left, so I would say it's about 5 to 6.
Not so easy.
It's the hardest.
That's the hardest.
Yeah. Yes.
And the position number 5, way out here.
Okay. Go ahead. You can definitely do it faster. Very good.
And then the pendulum, where the arms totally dangle, where it's no motion
Go ahead, just move here
at all.
a little bit.
Good.
Good, right there.
Alright, so now. What's the RPM?
You're doing about 7, 6, 7.
7 hertz. I'm doing that about maybe 400 RPM for the rotating ball.
Good to go.
Okay, so this is a resting position. I'm going to do a very standard rubber band exercise that specifically train the rotator cuff. Just one exercise, the so-called external rotation exercise. This is the elastic band that's commonly used in physical therapy and in training purposes. 1 inch of distraction is approximately 1 pound. So I'm exerting a total of about 15 pounds of force as I go through my external rotation. That's a continuous firing of the muscle. Continuous firing of the The other exercise would be an active diagonal exercise. As the arm goes in front of the body, diagonally. It's about a good 20 pounds of force. Okay, so this is just movement of the arm without the rubber band. But now I'm going to move along with the spinning rotation, the dynamic move of the shoulder sphere. And you can see the rapid firing, activation and deactivation. And then now I'm going to do the diagonal active. At rest, this is testing the infraspin. This is using the body blade, a very common device used in physical therapy and the training tool. Very good device. Just want to see how this dynamically works out compared to the other. So this is that position number 1. And you can see the infraspinatus firing as well.
Yeah.
How does the hertz compare to the
Hertz
ShoulderSphere?
is a little more because the waveforms are traveling to the right. So I would say it's easier than the sphere because you're getting more RPMs.
More RPM.
Yeah.
And then do the external rotation for the dynamic move. The active diagonal. So Dr. Rodley, so you can explain the hertz difference between the body blade and the
so
sphere.
the body blade you were able to achieve more in the range of 11 to 12 hertz, whereas the sphere you couldn't go beyond 7 to 8 at the most. And I think the sphere is harder to recruit. And I think the reason may be that when you're using the body blade, you have other muscles to assist you besides the infraspinatus. Whereas with the sphere, you're just isolating the infraspinatus, so it has to do all the work. Whereas in the body blade, you do get assistance from some other muscles, so it can work faster.
So that goes on to the next study, where you would see if I recruited my biceps.
Right.
Along with the use of the sphere versus the body blade.
Versus the body blade, yeah. It's impossible to totally isolate a individual rotator cuff in functional activities. You can do it in the lab, for example, but you know, when you're pitching, etc. I think the fact that it was much harder for him to fire the muscles with the sphere with the same frequency as, let's say, with the blade, where he could do it easy, tells me that the muscle was getting more of a workout with the sphere than it was with the blade.